Hello, physics, wave nature of light, flint glass prism, and grating. And the question is a parallel beam of light containing two wavelengths, 420 nanometer, which is blue, and 650, which is red, enters a silicate flint glass prism equilateral. What is the angle between two beams leaving the prism? This is A. B is a repeat A if diffraction grating is used. If is diffraction grating instead of prism is used. So first is a prism, and then is a diffraction grating. And a prism there are two. One is a blue light, and the other one is a red light. So first of all, the diagram is this one. This is a prism. This is a prism. This is a normal. This is another normal. This is normal 1. This is normal 2. So light enters at angle of say 45 degrees. 45 degrees. This is theta 1. This is normal. It goes instead of this one, this direction, and then it goes toward this one. So this is theta 1. This is theta 2. And this is a 90 degree. This is 90 degree. This is theta 3. And this is theta 4. This point is A, this is B, this is C. So blue at point A. So Snell's law. So this is N1 air, this is N2, this is N3. This is N1 again. So N1 sine theta 1 is equal to N2 sine of theta 2. This is 1, this is 45 degrees. This N2 is given 1.652 for at 620 nanometer, and theta 2 we have to find. If you find theta 2 using these equations, theta 2 is equal to 2534. Now use this triangle ABC. Triangle theta 2 plus theta 3 plus this 90b degree is equal to 180 degrees. So this will go to this one is 80, 90. So theta 3 is equal to 90 minus theta 2. So this one will give you theta 3 is equal to 90 minus this one 25, 34 degrees. This is theta 3 is equal to 34.66 degrees. So now applies at point C. Point C, Snell's law. N2 sine theta 3 is equal to N1 sine theta 4. N2 is known, which is 1.652. Theta 3 is known from 34.66. This is 1, and theta 4 we have to find. So theta 4 is equal to 69.96 degrees for 420 nanometer. Similarly, for the red, we can find out for as N1 sine theta 1 is equal to N2 sine theta 2. This is 1, this is 45 degree. This angle is 1.5 uh, 1.692. Okay, just a minute. So for red, which is lambda is equal to 650 nanometer. So we will apply this Snell's law at point A, here. So applying this one, N2 is equal to 1.619. So, and theta 2 we have to find from this one. Theta 2 is equal to, if we put the values, so this will be 2590 degrees. So this is for 650 nanometer. So this one is theta 2 for 420 nanometer, and this one slightly different. And if you use the triangle ABC triangle, so this one theta 2 plus theta 3 plus 90 degree is equal to 180 degrees. So from here theta 3 is equal to 34.10 degrees. So this one, so theta 3 here is 3466 and 3410, and then apply Snell's law again. Apply Snell's law at point C. So N2 sine of theta 3 is equal to N1 sine theta 4. This one is 1 point, which is here 1.619. Theta 3 is 3410 degrees, and 1 is 1, and theta 4 we have to find. So theta 4 is equal to this is equal to 65 degree 22, 65.20 degrees. So this is, so this difference, so the difference delta theta 4 is equal to 4.8 degrees. This one 69 minus 90 minus 65.20. So this is delta theta. So this is one answer. Now the diffraction grating. If you use the diffraction grating for 420 nanometer and 650 nanometer, so d of sine of theta is equal to m lambda. So say m is equal to 1, and we have to find the theta. Theta we have to find, and d is equal to 1 over 6020 lines per centimeter. So 1 over 6020, 6200 lines per centimeter into 10 power minus 2 centimeter per meter into sine of theta is equal to 1 into 420 into 10 power minus 9 meters. So from here theta 2 is equal to 15.90 degrees. So similarly for this one, 1 over 6200 lines per centimeter into 1 10 power minus 2 centimeter over meter into sine of theta, say 2 and 1 is equal to m is equal to 1 into 650 nanometer, 650 into 10 power minus 9 meter. So if 1, so theta 1 is equal to, this is equal to 23.77 degrees. So the difference delta theta is equal to theta 1 minus theta 2, which is equal to 23.77 minus 15.90 degrees. So this angle is 8.7 degrees. So this is the difference between the prism and the diffraction grating. So there will be more pronounced difference in grating compared to the prism. So this is the answer of this question.